Kaedah kawalan dari segi penggunaan racun bagi pokok rock melon, kita amat memerlukan bagi racun serangga dan racun kulat. Oleh demikian saya menggunakan secara manual, iaitu pam racun sandang untuk saya meracun di seluruh kawasan kebun. Okay, masalah yang dihadapi adalah dari segi ketepatan bacaan baja, kadang-kadang ada terlebih dan terkurang. So adalah sukar untuk mendapatkan satu jumlah bacaan baja yang tepat. Kaedah yang digunakan adalah secara bacaan secara titisan, iaitu saya menggunakan 220 ml bagi sekali siraman. Masalah yang saya hadapi adalah cara untuk saya mengawal ataupun memberhentikan siraman pada waktu hujan, disebabkan saya menggunakan siraman secara automatik.
Why we choose to do Laman Prosumer control system? It is because we wanted to help farmer to monitor their water level in the water tank by designing monitoring water level system using an ultrasonic sensor. Also, design a system that can monitor pH and temperature of water, and to help farmer to distribute fertilizer automatically by develop the system of auto distribution fertilizer to distribute the fertilizer equally to all the plant. Now we move on to monitoring system flowchart. First, the system is turned on. Ultrasonic sensor read level of the water, and if the water level is less or equal to 30%, then it will straight go to check first whether it was rain. If it's not rain, then the pipe turn on, then the water flow into tank. But if it's rain, then rain sensor turn on, and it will check first whether the rain level is more or equal to 3000, and then it will print rain level. After that, the water flow into the tank, and the ultrasonic read level of the water. If the water level is more or equal to 19, then yes, it will print water level. If it's no, then it will go up back to the water flow into the tank until water level reach 90%. After that, water pump turn off, and then pH sensor turn on. pH sensor read the pH water. pH value, this is the formula to search to get the pH value, and then we print pH value. And then DHT11 turn on. DHT11 read air humidity and air temperature, and then print air humidity and air temperature value. Now we move on to automatic distribution system flowchart. First, the timer turn on, then the water pump on, water flow to plant through pipe. Soil humidity sensor turn on. If the reading of soil humidity is more or equal to 30%, then it will go yes, it will print soil humidity. If no, that will go up back to the water pump. After that, mix to fertilizer with water. Then fertilizer system turn on. The pump turn on. Fertilizer solution flow to plant through pipeline. And then fertilizer system turn off. After that, mix pesticide with water. Pesticide system turn on. The pump turn on. Pesticide solution flow to plant through nozzle. Pesticide system turn off. Now, we move on to dosing system. First, the system is turned on. Water temperature sensor turn on. Send the data to monitoring system and print water temperature. Then, EC sensor turn on. K value was set to 5.1. Then, we get the EC value by using this formula. Then, EC value was print. After that, the system will check these three conditions, whether it is EC less than 1.5 but the water level is 100%, then water pump is off but dosing pump on. If the EC is equal to 1.5, then the water level is equal to 100% but the water pump off and dosing pump off. If EC is more or equal to 1.5 but water level is not equal to 100%, the water pump is on but dosing pump off.
This is the 3D design of our system. Firstly, we have 4 tanks here labeled as a water tank, fertilizer or mixing tank, tank for fertilizer A and tank for fertilizer B. The fertilizer tank is where we mix fertilizer A and B with water and the solution will be pumped out to the plants later. For the fertilizer tank, we put EC sensor to get the reading for the EC meter and also pH sensor to get the reading for the fertilizer pH meter. The water or fertilizer later then will be distributed by the drippers along the row and at all plants. And soil moisture sensor will be put randomly at any position or plant in each row so that plant receive the same amount of water. The white tank there we label as pesticide tank. The pesticide solution will be pumped out and will be sprayed out using a special spray nozzle from the top of the plants so that the leaf get the same amount of pesticide. Last but not least, we have a rain monitoring sensor. The rain sensor will detect the presence of rain and for rainy day, the water distribution system will be automatically turned off to save water and did not waste the fertilizer.
A Prosumer control system is a system that is specially designed for fertigation farm to overcome the limitation that faced by farmers in managing fruit farm or vegetable farm that make use of fertigation system. The sensor that we use are DHT11, an air temperature and humidity sensor. Raindrop sensor, a sensor to detect the presence of rain, a pH sensor to monitor the pH of the fertilizer solution, EC sensor to detect the value of EC or electric conductivity for solution, water temperature sensor, ultrasonic water level sensor to trace the level of water of the tank, soil humidity sensor to measure the soil humidity. If the soil humidity is below or equal to 50, farmers can run the pump because they know the plant receive less water. Did you know when a same quantity of fertilizer is mixed with hot water or cold water, the two solutions produced will give different reading of EC value? Temperature compensation prevent the situation from happening. For the monitoring plant system module, farmers are able to monitor the condition of the farm through LCD display on control box or blink application on smartphone or any device. Basically, our control system has 3 parts, which is monitoring system, automatic distribution of fertilizer and pesticides, and automatic dosing of fertilizer. The automatic distribution system of fertilizer and pesticides feature can be operated using blink application on mobile gadgets. Farmers just need to enter the start time and the stop time of the pump. The LED indicator turn on, which tell the farmers that the pump is running. This is the recommended pesticide sprayer nozzle position. This position and the type of nozzle allow the wide spread of pesticide to the leaves. timer runtime is based on the quantity of the fertilizer and pesticide need by each plant. For example, plant need to get at least 150 ml of fertilizer at each session. The pump need to be turned on for around 1 minute. Same method of timer is implemented for the automatic distribution of fertilizer. When the timer starts, pump will pump out the solution from the tank. But fertilizer use dripping nozzle so that the solution diffuses slowly to the soil and can be easily absorbed by the root.
Automatic dosing system. In order to manipulate the EC value, the system needs an access for authentication to make the system become secure. So we just enter the pin that we have set. And now we can change the EC value to get the fertilizer ratio following the age of plant. The green LED indicates the dosing system will operate. So the dosing pump will turn on to get the fertilizer A and B into the main tank. So it will turn on until it's reached the ratio that we have set in the system. So only the authorized person in charge in the farm can change the EC value with the right pin number. So otherwise, the access will deny. Water level monitoring. So the system will automatically refills the water tank when the water level falls below 30%. It's determined by the ultrasonics and it will fulfill the water tank until 100% of the tanks. Next, this system can be directly controlled from the mobile phone, which is Blink application. As example, we turn on the pesticide system from the apps and turn off the system when needed. We can look at the red LED indicator. So, for the case if the control box cannot connect to the Wi-Fi or trouble, we still can use the manual switches to control and to turn on and turn off all the pump using the manual switches.
Fun fact of project. The budget for our project is, our budget for the project is Rm 545 ringgit 43 sen. Our justification for the budget. With this budget, we can produce big-scale project for 100 to 200 trees. Significance of the project. First, accuracy of EC fertilizer measurement. Second, monitor the farm from your fingertips only. Third, reducing the workforce. Fourth, improving yield and grade of plants. And low budget cost fertilization method for new farmer.
USIM emphasized the significance of preserving biodiversity while also pursuing sustainable development based on the 17 SDG components. SDG goals that we focus on our projects are, firstly, Goal 2, which is Zero Hunger. Our project is to improve nutrition and also promote sustainable agriculture. The next goal we focus is Goal 9, which is Industry, Innovation and Infrastructure. In this project, we develop resilient infrastructure, encourage inclusive and sustainable industrialization, and also support innovation. Next, we also focus on Goal 11, which is Sustainable Cities and Communities. Our project does not include any hazardous or damaging materials to the environment. It can help to preserve the environment and nature. Last but not least, we'll also focus on Goal 15, which is Life on Land. This initiative is anticipated to enhance the agriculture sector's productivity, allowing them to produce high-quality products. As conclusion, our project focuses more on how to apply the fertigation to the plant and also to overcome the limit that the farmers has faced. We also integrate the fertigation with Internet of Things as we use Arduino and Wi-Fi module in our project. It is because we can control the system and monitor the system by the tip of our finger. We hope that the success of this project will allow us to fulfill all the mentioned goals.